Hi everyone, welcome back to JDCodebase. In the last video, we solved some basic linked list problems like finding the length, middle element, and the nth node from the end. Now, in this video, we will move to slightly advanced ones. So, we will solve three very important and common interview problems: detect a loop in linked list, remove duplicates, and merge two sorted linked lists. Alright, let's get started with the first one: detect loop in a linked list. So what does loop mean in a linked list? Normally in a linked list, each node point to the next one and the last node point to the null. But in a loop list, one of the node point back to the previous node. So it creates a cycle. For example, I will show you a diagram. Uh, so in this diagram, if you see, this is a simple linked list. Every node point to the next one, and by using this arrow, and the last node point to the null. But in the loop, in the cycle linked list, last node is again moved to the previous node in a cycle form, in a circle form, like here, and then again previous node. So this to check if a loop exists, we use a simple but smart method called Floyd cycle detection algorithm, and it is also known as the tortoise and hare method. The idea is simple that we take two pointers. One is slow and one is fast. The slow pointer moves one step at a time and the fast one moves two steps at a time. If there is a loop exists, both pointer will meet at some point, and if there is no loop, the fast pointer will reach null and stop. So let's move to VS Code and write the code for this. So I already write the class node and with the constructor and the class linked list, and we have to write this detect loop. So here I have to initialize the two pointer. Let slow is equal to this dot head, and let fast is equal to this dot head, and after that we also have to initialize the check, means is loop is equal to true or not. Initially we say it is not in loop, so we say it false, and start a while loop while fast is not equal to null and fast dot next is not equal to null. Then we have to check whether means traverse the slow by one step, slow dot next, and fast is equal to fast dot next means two step. Fast move two step and slow moves one step, and check if slow is equal to fast, and if both are the equal, we have to convert this is loop into true and break this loop. After that after this while loop, we have to return this is loop. So basically first here I am taking the two pointers slow and fast, and both starting from the head. Then I will move through the I will move slow one step and fast two step at a single time in a loop. And if at any point they both are become equal, it means the linked list has a loop. Otherwise, if fast or fast dot next becomes null, that means there is no loop. And here I already create the linked list with the value 10, 20, 30 and 40. In a simple linked list, if I make this and run this, I get there is no loop, and let's traverse this list dot traverse. If I run this, I will get 10, 20 and 30 and 40, and there is no loop. If I make them into the loop, means head dot next dot next dot next, with the it point back to the head dot next, means the 20. If I run this, now you will see this is going into the infinite loop. If you see 20, 30, 40, 20, 30, 40 every time, means it is going into the infinite loop in a circle form, in a cycle form, and this 40 connect to the 20 here. So let me comment this. either it will move into again infinite. Yes, now it's a loop detected. I call this list or detect loop. If yes, loop detected, else no loop. So this is the detect loop method for this. So now our second one is the remove duplicates from a sorted linked list. So in this problem we are given a sorted linked list like 1, 1, 1, 2, 2, 2 and 3, 3 and null. So our output is the 1, 2 and 3 null. Means we remove this 1, this 3 as the this is the duplicates. So it is simple, since the list is already sorted. All the duplicates will next to each other. We can take one pointer called current and simply compare current.data with the current.next.data. If both are equal, we skip the next node. If not, we move ahead. So let's write the code for this. So I already write the class node and class linked list for this, and we have to write this remove duplicates. So let's make a copy of this linked list into this current and start a while loop. Current is not equal to null and current dot next is not equal to null, and if current dot data is equal to current dot next dot data, we have to, means if they both are equal, we have to skip this. Means we have to current dot next is equal to current dot next dot next, else we have to just move traverse this simple current dot next is current is equal to current dot next. As simple as we traversing like here, current is equal to current dot next, and in last we have to traverse this to check this dot traverse, and let's run this. Wait, node 2. I get before the linked list is 10, 20, 30 and 40. That means 2 times 30 appears in this linked list, and after these remove duplicates it becomes 10, 20, 30 and 40. So basically I'm starting from the head of the linked list, and inside the loop I will check if current.data is equal to current.next.data, then I will skip the next body by linking current.next is equal to current.next.next, and otherwise I will move my pointer to the next node by current.next. That's it. It's a very simple and clean logic. And so next one is the merge two sorted linked list. So we are given two sorted linked lists. First one is the 1, 3, 5 and second is the 2, 4, 6. And if we need to combine them into one sorted list like this 1, 2, 3, 4, 5, 6. The idea is simple. We take the two pointer L1 and L2, and whichever is smaller we will attach to our result list and move that pointer ahead. We will keep doing this until one of the list becomes empty, and then we will attach whatever is left from the other list. Simple, like we already did in the array also. So let's move to VS Code and write the code for this. So here I already write the linked list. List 1 is the insert at 135, list 2 is the 246, and we already traverse this. Let me traverse. I get list 1 is 135 null, list 2 is 246 null, and merge list is null because I did not write the code for this. Let's try this. So first make a dummy list. Let dummy is equal to new node. Make a new node, dummy node with the -1. Whatever you want to, means 0 or -1, and let make a tail is equal to dummy. Then start a while loop and it runs till head 1 and head 2. And if head 1 dot data is smaller than head to dot data, means we have to insert the tail dot next is equal to head 1, means we connect the head 1 dot data head 1 to the tail, and we have to also move forward in the head 1 is equal head 1 dot next, else tail dot next is equal to head 2, and again head 2 is equal to head 2 dot next, and we also have to traverse this tail every time, tail dot next. So if after the loop is finished, means head 1 and head 2 is one of them is over, then being if any of the elements are left in the head 1 or head 2, then we have to also insert them. If head 1, then tail dot next is equal to head 1, means just attach whole the list in the end of the tail. And if head 2, again same next is equal to head 2, and return this dummy dot next. Let's run this. Now if you see, I get 1 2 3 4 5 and null. So first I created a dummy node to help build the new list easily. Then I took a tail pointer to keep track of the end of the merge list. And now I am comparing L1.data, means list1.data with the list2.data. And whichever is smaller, I will attach the node to the tail.next. Means if head1.data is smaller, we attach the tail.next is equal to head1. Else tail dot next is equal to head 2, and then we also move the pointer ahead, like head 1 is equal to head 1 dot next, head 2 is equal to head dot next. At the end I will attach whichever list is still left, and finally I return this dummy dot next, means if anything is left in the head 1, we attach the tail dot next is equal to head 1, and if head 2 is left with something, and then we test tail dot next is equal to head 2. If I run this, I get 1 2 3 4 5 6 and null. So this is the merge sorted list here. So in this video we solve 3 advanced linked list problems: detect loop using the Floyd algorithm, remove duplicates from the sorted list, merge 2 sorted linked lists, and all these problems help us understand pointers and link manipulation much better. If you practice this properly, you will become very comfortable with the linked list. In the next video, we will explore doubly linked list in JavaScript. So make sure you do not miss that. If you find this video helpful, don't forget to like, share and subscribe JDCodebase for more short and practical DSA tutorial in JavaScript. Thanks for watching, and always keep practicing in your